Hello everyone. Today we are learn about the topic particle in two-dimensional and three-dimensional potential box. Right. So here we have to manipulate problems with the manipulate quantum numbers. To be introduced the concept of non-singular modes, generacy and degeneracy. Here we have to consider two-dimensional square well. So Schrödinger equations for an electron confined to a two-dimensional box like x and y. That is, say within this rectangular, okay, so rectangular, the electron wave functions behaves as free particle, that is v of x comma y is equal to 0. So potential energy is 0 between x equal to 0 and x equal to L1. The same y equal to 0 and y equal to L2. In this case, particle is confined to surface x comma y. So within the width x is a and y is b. Now here extending the time dependent Schrödinger equations for one-dimensional system, that is h cross squared divided by 2m. So d squared psi x divided by dx squared plus v of x psi of x is equal to e psi of x. So in this case, the potential energy v of x comma y is given by 0, that is for 0 greater than x greater than a and 0 greater than y and greater than b. So two conditions there, 0, another one is infinitive. So 0, in this case 0, so x greater than or a and 0 greater than y greater than b. So infinitive for all x and y. The Hamiltonian operator is given by, so minus h cross squared divided by 2m d squared dx is divided by dx squared plus d squared divided by dy squared. So plus v of x comma y. The corresponding Schrödinger equation, h squared divided by 2m d squared psi. So here we have to take it as two coordinates x comma y divided by dx squared plus d squared psi of x comma y dy squared is equal to e psi of x comma y. So inside the potential box and psi of x comma y is equal to 0, this is outside the box. Now particle in a two-dimensional, so minus h cross square divided by 2m d squared psi x comma y, we have separated x and y. So psi of x divided by psi of x is equal to ex and minus h cross square 2m d squared by dy squared psi of dy divided by psi of y is equal to ey. So inside box psi of x comma y is equal to 0. Outside the box, the wave function inside the box can be solved by separations of variables. Psi of x comma y is equal to psi of x, psi of y, which can be shown to lead to the equation. So this one is, so minus h cross square divided by 2m d psi of x divided by dx squared equal to e x psi of x. The same y coordinates, minus h cross square divided by 2m d squared divided by d squared psi y dy squared is equal to e of y psi of y, right? So this is simply the product simply product of a two-dimensional particles in 1D becomes, so we have psi of nx, or psi of nx is equal to root 2 by a sine nx pi x pi a. The same y-axis, so psi of nyy is equal to root 2 b sine ny pi y divided by b. So finally we can, the energy function En of x equal to nx squared h squared divided by 8m a squared, then y, so En is equal to ny squared h squared divided by 8m b squared, right. So psi function, psi of x comma y is equal to, we have to add both the x and y axis. So x and y axis is equal to 2 divided by root a comma b, ab sine nx pi x divided by a sine ny pi y divided by b. The same energy level E nx ny is equal to h squared 8m nx squared divided by a squared plus ny squared divided by b squared. And energy of the particle E is equal to E nx plus E ny. Already we know that the value of E nx, so E nx is equal to nx squared h squared divided by 8m a squared. Here number of atoms nx is equal to 1 2 3, and the same y axis. So Ey is equal to ny squared h squared divided by 8m b squared. Here a and b both are width are the same, so now we have to consider b is equal to a, so a squared. So En of x ny is equal to, we have to add both equations En of x En of y, h squared, the common term h squared divided by 8m a squared. So h squared divided by 8m a squared, remaining n x squared plus ny squared. Though similarly the three coordinates, three-dimensional potential box the same. So E nx, ny, nz is equal to h squared divided by 8m a squared, nx squared plus ny squared plus nz squared. So this is the energy of the particle. And now wave of the particle, wave function psi of nx ny. So psi of nx is equal to root 2 by a sine n pi x divided by a into root 2 by b sine ny pi y divided by b. So we have to add both nx ny, psi of nx ny equations. So here 2 are 4 divided by a into b. So root 2 4 by ap sine nx pi x divided by a sine ny pi y divided by b. So similarly the three-dimensional potential box we can write like this: psi of nx ny nz is equal to root 2a sine nx pi x by a into root 2 by b sine ny pi y by b into root 2 by c sine nz pi z by c. So the lowest energy state nx equal to ny equal to 1. Okay. So a greater than b அப்படினாக்க the next lowest energy state is nx equal to n2 and ny is equal to 2 and a equal to b. We have degeneracy nx ny equal to eny enx, both are the same. So wave functions with different quantum numbers, these are the different quantum numbers, but we can get the same energy are called degeneracy. Okay, here nx is equal to 3, ny is equal to 1. Here nx equal to 1 and ny is equal to 3. So wave functions are different, 3, 1, here 1, 3, but energy levels are same. So that is called the degeneracy. So here we have to give one problem for this two-dimensional and three-dimensional program. So a particle of mass m is equal to 9.11 into 10 power minus 31 kilogram meter and is confined in a two-dimensional rectangular box with the dimensions Lx equal to 1 nm and Ly is equal to 2 nm. Here calculate the first three energy levels E11 of particle. Second one, determine the wave functions corresponding to these energy levels. Solution: first we can find the value of energy levels. Enx ny is equal to, this is the formula of energy level, so h square divided by 8m, here nx square divided by a square plus ny square divided by b square. So already we know that the value of mass m is equal to 9.11 into 10 power minus 31 kilogram and Lx 1 mm, here we have to convert nanometers, that is 10 power minus 9, Ly is equal to 2 nm, 2 into 10 power minus 9. We can substitute these values in this formula. So Eny, this is the energy level 1 comma 1, here energy level 1 comma 1, so x values x energy level 1, y energy level 1. So now we can write like this, En1 n1, okay, equal to here nx squared. So what is the value of n? Number of electrons. So 6 into 6 to 6 into 10 power minus 34 the whole square divided by 8 m, that is mass value 9.11 into 10 power minus 31. Here nx squared. So nx is equal to 1. So 1 squared divided by a. So a squared is equal to same 1. So 1 squared plus here Ly values 2 nanometer, 2 into 10 power minus 9 divided by y, b squared breadth is 1. So 1 squared. So finally we can get the energy level E11 is equal to 7.59 into 10 power 20 joule. Second one, determine the wave functions corresponding to these energy levels. So energy wave function formula, this is the wave function formula, psi of nx ny is equal to root 2 by a sine nx pi x divided by a into root 2 by b sine ny pi y divided by b. So already we know that value of a and nx. So a is equal to 1, b is equal to 1 and nx equal to 1 and ny is equal to 2. So we can substitute this equation, psi nx ny, that is 1 1 x comma y. So x comma y, it is 1 comma 1, right, equal to root 2 by a sine pi x by a into sine pi y by b. So here we can write like this, psi of 1 comma 2, the value of this is the first order, second order, psi of 1 comma 2 is equal to root 2 ab sine, here x values is 1, so pi x by a into sine y values are 2, so 2 pi y by b. And thank you so much for your patient listening. Thank you.